Well, thank you. You made it to day 3. And you're all here almost at 3 p.m. or 2 p.m. So you must either really care about BMCs or security or both. So thank you for being here. My name is Darpana. I am the person that people know me as giving you a hard time about hardware security requirements for Microsoft. And I love doing my job, so thank you. And I'm very happy to introduce my co-presenter. She's wonderful, Elaine.
Hi, I'm Elaine Palmer. I'm from IBM Research. My background is all the way from mainframe security down through HSMs, down through smart card chips, and now I'm working on chiplet security, so I'm down at the really smallest level. I don't know if I can go any smaller. Atoms, I don't know.
She's too humble. She does great stuff. Thanks. So thanks everybody for joining us. Elaine and I and Jeff and Brian, there are lots of things that are kind of pending in the OCP security workgroup, right? I guess big things that need to be tackled. You've heard about OCP Safe. You've heard about kind of standardization of requirements, with the OCP Secure Boot spec or attestation. They're all things that are building security ground up into the components, I think, proactively thinking about security. And one of the areas that's a little bit untapped in terms of kind of thinking about security, I think, was in the BMCs. And so we thought, this is something that needs to be tackled. And Jeff said, we need volunteers. And so Elaine and I thought, okay, we can do something together, and we thought we'll pick this up. So that's kind of how this started. So today we'll talk about a little bit why we're doing this. I think most of it should be obvious, but we'll still kind of touch upon it a little bit. What is our goal with this work stream in the security work group? A little bit about the structure and content of the document that we'll produce as a result of it. And of course, in true OCP spirit, we'll invite you for some call for action. All right, so what's a BMC? Most of you know about that, I think. But it is on most devices like a hardware management SOC that is usually there for remote management, control, diagnostic, and recovery. And really, if you think about them, they really have access to everything on the system. So typically, last few years or a decade or so, I think there's been a lot of investment in security for the host, rightfully so. But if you think about that as the brain of the system, then the BMC is considered like the brain stem, right? Because it accesses everything. And so typically they say if you own the BMC, you kind of own the system. And that's why they're a lucrative kind of asset for malicious actors to kind of compromise. And so, we want to think about the BMC security. If you look at that, we see lots and lots of vulnerabilities coming in. We think that the hardware and security for the BMCs is slightly immature, needs some work. And we really need to design BMCs securely from the ground up. I think that's kind of where we are today. Lots and lots of vulnerabilities. I took a look at kind of, before we came on, I was like, oh, let me look at how many critical or high there are on the, CVEs. And there were like a bunch of 9.8s. So that's pretty high and critical, right? And they're coming in fast and furious every day. For us, whether, you heard in OCP Safe, Andreas, Brian talked about it, Amber, there is legal liability associated with kind of building an insecure device. And so, as a supplier, you're thinking, what do I do to make it secure? And how do I make it secure such that, Google is happy, IBM is happy, they're doing the right thing. I think the intent is there, but probably the guardrails or the guidelines are not quite, clear and existent. So I think that's kind of where we want to help a little bit. So what's our goal? We want to identify important key security features of the BMC. We're not going to reinvent the wheel with anything that is already, we're going to leverage what's out there. If you think about Calyptra, implementing a root of trust, you can either choose that or do something else. It could be different things and specific to the BMC. We want to be able to provide some technical guidance to system vendors, BMC manufacturers, and make sure that there's consistency in that. And provide an interface such that there's an implementation freedom, but there's clear guardrails for what needs to get done. And then finally, really want to invite open collaboration in this space. We want to design BMCs securely from the ground up, really want to raise the bar on security. And like if you think about Microsoft and the number of meetings I'm in for how to secure our BMCs, it's probably half my time these days. So it is an area that I think we all want to invest in heavily, and I think that's across the board. So the work that we're trying to do is kind of in that space. With that, I'll hand it over to Elaine to talk some more about her pieces.
Thanks, Darpana. Good, excellent introduction to our problem here. So as we started to write this document for the guidelines and guardrails for BMCs, having been the editor of the attestation spec for OCP, I thought this was going to be easy, but that was not the case. And as we began drafting, we came across question after question. Some of the questions are here, not all of them. And I think we need to have, at least in the security group, the work group, and in other groups like Open BMC, we need to discuss these questions, resolve them, and see if there is some resolution that will make people happy and will work. So, for example, the number one thing we have now as we draft is, are we trying to document the journey towards this ultimate secure BMC, or are we documenting the North Star? Like, this is what our target is, and we're not going to compromise on how we get there. That you might have to make compromises, but this is the ultimate of what we want. We have, of course, what kind of identity do we use for each device, each BMC? You can choose something unique or follow dice. Even whether you have a TPM or not, a discrete physical TPM, or you have a firmware TPM, or you don't have any TPM at all, are we going to require something? The BMC has its own internal stack, right? It's got its own boot, secure boot, we hope. It's got its own firmware. It has its own operating system. It has its own applications. It has its own users and groups and roles and authentication and authorization. So how much of the BMC should we attest? We know we need attestation, right? But how much of it? Do we only do the firmware? Do we do the whole stack? So we need input on this stuff. Keys, that was, Matt talked a bit about the setting ownership and provisioning. Do owners or those who put the BMCs in their installations, do they need to be able to control the keys and the firmware themselves? What about vendor keys? Can they be replaced? Do we use Linux? OpenBMC uses Linux, but there are other even more secure embedded OSs. Should we consider something like that? And of course, now BMCs are being consolidated. Do we just want all the features of memory and TPMs and all of that wrapped into one piece of silicon? Or do we want, and will we allow discrete components? The document itself is, here's the table of contents as it is about a week ago. The structure follows, in general, common criteria. And why does it follow common criteria? In fact, as we started off, we had different kinds of outlines and approaches to it, and finally settled on this one because what common criteria provides us, not that we would go for a certification necessarily, you could, but it gives us checklists. It's like a menu of, for audit, for example. Do you have audit logs? Who or what authority is it that can clean out those audit logs? Who can see the audit logs? All of that kind of stuff is in the common criteria to remind you, hey, did I think about that stuff? And so all of these things have more details, but they're all there to trigger us to follow the advice in common criteria, whether or not we go on for more. You'll see on the left side, it shows what can the device do, what does it do, and these are only security-related things. We're not talking about all the rest of the features of BMCs, but just the security features. And on the right side, that covers how well was it developed, what's the documentation level, all of the things that are related to development and creation of this device. Now, we are not the only people working on this. I was surprised to learn that Huawei, for example, has already gotten an approved international protection profile. It was done in France. And it is for a protection profile gives you a generic description, a description of a generic product, and your product would need to document more of how it meets that generic description or protection profile. So that's already out there. It's not a very strict and rigorous requirement on BMCs, but it's there, and it's international. So you would expect to see it, for example, in being required in Europe fairly soon. The second one, again from Huawei, is a different product. They're intelligent BMC. And here they have a certification already done, but it didn't follow their protection profile. It went beyond that. And there are many, many security features in this, this Huawei IBMC, and it's all documented. You can see the security target online. And then I'm really not sure who Xfusion is, but they have the same security target in a different name product in a different company, but it looks just like the one from Huawei. But there you go. It's already there. Now, how are we going to do this? We've started, as I said, we're probably, I don't know, maybe halfway through, I guess, in the draft. We have an initial draft. But we need more input from the OpenBMC community and the OCP security folks. The OpenBMC folks, there are a few that are security experts, but in general, the OpenBMC community is not really deep in security. So we have to combine our knowledge and with our security knowledge and their BMC knowledge to come up with this. Of course, once we have all the meat on the bones, you just saw the bones a minute ago, then we'll review the draft with the OCP security project and the OpenBMC community, incorporate their feedback, and that'll be a loop because, you know, more we change, the more there'll be more feedback. Once we finally decide to stop iterating, then we go back to the OCP security project for a final approval, and assuming that it is approved, then it moves on to the OCP incubation committee for approval. So our call is there are many ways you can help if you are interested. Or maybe it's in self-defense because you want to make sure that your product's features are in it or not excluded. If you want to be a co-author, let us know. If you have feedback input, let us know. And a really helpful thing would be when we do have all the meat on the bones to be a reviewer. That it's really, really helpful to get feedback. Okay. So that's pretty much the end of the talk. The takeaways are, as Darpana described to us, the threats are real. The resources that attackers have are definitely extensive to the level of nation states. As cloud vendors and enterprise system vendors, we need secure and resilient BMCs. The vendors who build these BMCs need input because it takes multiple years to go from idea to production, and they need input now. And finally, if we welcome open collaboration so that we can harden not just the silicon, the hardware, the firmware, but all of that combined to raise the bar on BMC security. And the usual OCP, how to get involved. And that's it. Questions? Anybody want to throw eggs and stuff, tomatoes?
No T-shirts, by the way.
Oh, no. My question is, I think last year Microsoft presented on Project Hydra, a secure BMC. Would that be an interesting case study to say how it compares against these requirements being developed so far?
Yeah, for sure. So a lot of the things that we're thinking about here would kind of be, part of Hydra already. There might be things that are kind of maybe firmware related or other pieces that are, up or higher in the stack that may or may not be there yet. So I think you're right. It will be a great case study, and we'll make sure that kind of, it feeds into the Hydra BMC for sure.
Thanks.
Yeah, no worries. Thanks for the question. Sorry, no T-shirts. Jeff.
I'm offended by lack of T-shirts.
Oh man, I'll buy you one.
One of the degrees of freedom you mentioned was attestation, whether firmware only or full stack. I wonder if you could elaborate a bit more on the delta between those two, what that looks like.
Yeah, you want to take the word from me?
Yeah, so it's very similar, in fact, to a complete system, right? That what's on the outside catching it and what is verifying it, how would it even know what the BMC's boot firmware looks like after it gets through the BMC and then all the way up through your system? And the question there is, do we have multiple levels of, they can be stacked, right? But the verification on the outside may only know about one level to be able to verify. So it's the same issue for BMCs. And I don't think that's been resolved for systems or BMCs.
Thanks.
So, wait, I have a joke. I wanted to tell a joke that was related to this. I couldn't find one, but I found another one, which was, my password was compromised, so I had to rename my puppy.
All right, thank you, everybody. I know it's quite late, so I appreciate your attendance. Thanks.